So this is the second of the videos talking about three-dimensional similarity and functions in geometry and probability review. So this is the second video, the back page number 9, and then the probability stuff. So number 9 here is asking us to write the volume of a cone as a function of its height. Okay, so as a function of means it can only have h in its equation. Okay, so in all of these problems we start off with the volume of your cone because that's the picture that we have. So 1/3 pi r squared h is the cone volume formula. Okay, and as you notice it has two variables in it. It's a function of the radius and a function of the height. But we don't want it to have r and we just want it to have h. Right? So we can't just erase it because that's not the way math works. We have to find some way to replace it. And we replace it with what it equals. So whenever we're doing these type of problems, the second equation that relates the radius to the height is a ratio. Okay, because we have ourselves a right triangle, every radius and height for a cone make a right triangle. We have a proportional relationship between the radius and the height. So we go to our problem and we notice that it has a maximum diameter of 12. Right? That's what the maximum diameter of our cone is going to be. So the radius is going to have a maximum value of 6. And it says that the height of our cone has a maximum value of 8. So this is where these numbers come from. Your 6 and your 8 are used in your ratio. Okay, so because we wanted to solve for r in the orange equation, we need to, replace r in the orange. We need to solve for r in the proportion. Okay, and all cones have this proportion. So we're going to multiply both sides by h because that's what gets r by itself. And we find when we simplify, because we can simplify 6 over 8, what does 6 over 8 simplify to or reduce to? 3/4. So the radius is 3/4 of the height. Okay, and we're going to write it like that with our h and our numerator next to the 3 rather than 3/4 and then the h. So now that we know that the radius equals 3/4 of the height, we're going to take this fraction and we're going to put it right there. We're going to replace r in your volume formula with the equality that we just made, right? We just said r equals from your proportion. So instead of r, we're going to have 3h over 4. Okay, because that's how the radius relates to the height. The radius is 3/4 of the height, so the radius is smaller. So now we're going to have to do some simplifying, and sometimes this is the hard part. So we have to square the 3, we square the h, and we square the 4. We square all of the pieces of your fraction. Okay, so that turns into, let's see, 3 squared is 9, h squared is just h squared, and 4 squared is 16. So our last step in simplifying is multiplying your denominators together, right? We have a 3 as a denominator and a 16. 3 times 16 is 48, and then everything else goes in your numerator. 9 pi and h to the 3rd power, because I have h squared times h squared times h is h to the 3rd. Okay, now this is a pretty good equation. Right, it has one variable, 1 pi, and a fraction. The thing is, can we reduce 9 and 48? So if you don't reduce 9 and 48, it's still correct. But in fact, we can reduce 9 and 48. Both of these have a multiplier of 3. So if we divide them both by 3, I get the equation 3 pi h cubed over 16. Okay, now that's the best equation because it's in its most reduced form. All of the numbers we're going to get are be the smallest when we use 3 pi h cubed over 16. Okay, your answers can still be correct with 9 pi h cubed over 48, your numbers will just be larger than the other way around. Okay? Good to know. All right, so now that we have our equation, we can start answering these other questions. If there is originally 20 cubic feet of water in the tank, right, that's your volume, what is the height? So we set your 20 equal to that formula that we just came up with, 3 pi h cubed over 16. We set the actual volume equal to the formula. And now we have to solve for h. And there's a 4-step process. First step, multiply by 16, right? You want to get rid of your denominator. The next step, divide by 3. Get rid of your number. The next step, divide by pi. Get rid of that. And the last step is to take the third root of whatever number is left on the left side. Okay, so there's always 4 steps to solving for h. To multiply by your denominator, divide twice by your number and your pi, and then take the cube root. Okay, and if you do this math correctly, and there's your height, 3.238. Okay, so anytime you want to know the height of the water or the depth, right, it might be called the depth. How deep is the water? What's the height of the cone of the water? It's the same thing. So part C, how much water is in the tank after 10 minutes? So to answer this question, we go back to the rate. How fast is the water being filled up? And that says at a rate of 4 cubic feet per minute. Okay, so we can come up with this equation that the volume of water is 4 cubic feet every minute, so 4 times t, t stands for time, 4 feet per minute, plus there was originally 20 feet of water in the tank. So we can't forget about how much water we started with. Okay, so your formula is always rate times time plus the initial amount. Sometimes there might not be an initial amount, but in this case there is an initial amount. So you take your 10 minutes, you plug it in here. 4 times 10 is 40. 40 plus 20 is 60. So after 10 minutes, there is 60 cubic feet of water in your conical tank, right? Your tank shaped like a cone. And the next question, what's the height of that water? Well, we know that the volume is 60, and we know the formula is 3 pi h cubed over 16. So once again, we do the exact same steps. You multiply by 16, divide by 3, divide by pi, and take the cube root. And when you do all of that wonderful math, right, that algebra, we get a height of 4.67 feet. And our last question is when? When will the tank be full? So when is the time question? And in order for us to answer the when question, we need to know the volume, because the volume has a rate of 4 cubic feet per minute, right? T is your variable. So we know that the volume is 4 cubic feet per minute plus 20, right? The original 20. So what we need to do is calculate the volume of our tank when it is full. Okay, so we're going to use our same equation, 3 pi some height cubed divided by 16. And the maximum height of our cone is going to be 8. Okay, so you plug an 8 into there, and we get a volume of 301.593. Okay, so that's the volume of your tank when it's full. There's 301 cubic feet of water, and we set that equal to our formula 4t plus 20, right? That's our volume rate time formula. 4 cubic feet every minute plus our original 20. Okay, so minus 20 and divide by 4, and it would be full after 70.4 minutes would be the final answer. Okay, so there is going to be a volume of a cone that is increasing at a certain rate on your test. Okay, so learn these steps. Learn all these steps. Okay, and the last topic is this probability stuff. So here we have a chart. This is conditional probability. So we're figuring out how many kids we have divided by the total number of kids. Okay, so there are 389, that's the total number of students. So what's the probability that it's going to be a female? So we have 240 total females divided by 389 total students. Okay, so we do 240 divided by 389. We multiply that by 100 and we get 61.7% of these students were girls. Okay, what's the probability that it likes science? So we want science kids. There are 86 total kids that like science the best. So 86 out of 389, right? These are kids that like science. So we look at the total boys and girls that like science. Okay, and that is 22.1% of kids that like science. What's the probability of a kid that likes social studies or art? So we're looking at social studies. There are 28 kids that like social studies, and there are 66 kids that like art. So we add together those number of kids, and we're still dividing by 389. And that gets us 24.2%. So 24.2% of kids like social studies or they like art. Now we're getting to some conditions, right? Given that you pick a male, so we're only looking at the boys now. So we're only looking at the boy row. There are 149 boys. What's the probability that he will like music? So we have music. There are 13 boys that prefer music, so 13 out of 149. Okay, so we're only talking about boys, not the whole entire student population anymore, and that gives us 8.7%. Okay, given that you pick a student that likes math, so we're only looking at the math column now, right? The kid has to like math, so we're only looking at 92 total kids. What's the probability that that will be a female? So we have 68 of our math kids are girls, so 68 over 92, because we're only looking at the math kids. And 73.9% of students that liked math were girls. And the last one, what's the probability that it would be a girl who likes social studies? So there are 22 girls that like social studies, or a boy who likes music. There are 13 boys who like music. Okay, so these or questions mean we have to add together those probabilities, those quantities of kids before we do our division. So 35 divided by 389 is 9% probability that we'll get a girl who likes social studies or a boy who likes music. Okay, so there's the back side of your review. Hopefully this helps you and your brain is going to be locked in for your test. Okay, goodbye.